For the rocketry part, basically anyone nationwide can propose to compete. They have to write a scientific proposal, a technical proposal. We review it, and those that are accepted, then it becomes an 8-month project where they go through the engineering design process, and they have to do design reviews and meet with us and get an okay to proceed to the next step. And so they designed the rocket to launch. What's new this year is they launch to an altitude of their choosing. So they get to choose, but they have to tell us 1 month into the project, this is the altitude we're going to, and then they have to stick to that. So it's challenging because they have to do all the computer simulations and tests to make sure that they're right, because we give an altitude award.
Okay.
The second part of that is the payload part. And this year for the colleges and universities, they could either, once the rocket lands, they have a rover that autonomously deploys, and it drives 10 feet in any direction and collects a soil sample. That's the first choice. The second choice they had was when the rocket lands, they could actually deploy a UAV, an unmanned aerial vehicle, like some of the drones or quadcopters that many hobbyists fly. And they have a beacon, and they take it to, we call it a TARP, or a future excursion area, and they have to drop the beacon on that spot.
This is called an avionics sled. It contains all of the electronics and altimeters required to locate our rocket after it lands and control the parachute deployment during the flight. So these are 2 altimeters. On the reverse side is a GPS locator. So this makes sure that our rocket descends safely and lands without hurting itself or anyone else, and make sure we can find it after.
We were finishing up the final touches on some wiring, and I saw a poster of a Blue Angels plane, and you know, when you have the full rocket, it's got the same triangle design that the Blue Angel has on its back. And then we have the N-Star for Navy, and then 19 for our class year.
It was very challenging. Everything from figuring out how to make these hinges work to figuring out how heavy this thing was allowed to be just to fit into our rocket, and also to meet the requirements that NASA put on it. We couldn't just use a little UAV because this thing has to fly in 20-mile-per-hour winds a quarter of a mile away potentially. So didn't have to do that today, but we had to be prepared for everything.
We learned how to work through the engineering curriculum, work through the pipeline of going from a concept to a design to building something, and we learned how to work as a team, and I took that away, and that was honestly very inspiring.
We're always so amazed at their creativity and their ingenuity. What it teaches is it's really taking the classroom concepts of science and math, and it's applying them into the real world. So when you learn about forces and Newton laws and all that, then this is why you learn them. So they get to see the hands-on side of science and math, which I think makes it a lot more fun, and they learn a lot more.